So today we're talking about derivatives of inverses of functions. In last class, we examined two functions that were inverses of each other, e to the x and log x, because they undo each other. Today we're just going to be talking about inverses of just any function and what the derivative of the inverses are in general. Okay, and key to inverses is that if we have two functions, say f and g, and if f and g are inverses, and say I have g of x, I want to just get x from g of x, I take f of it. And f will undo what g is doing to x, and it'll just give me x. It'd be the same way around. G of f of x, whatever f is doing to x, g would undo it, and it would just give me x. Now, looking at inverses and understanding this property, we can look at y equals x squared at the point 2, 4. Let's say this is not y, let's say this is f of x is equal to x squared. Okay, well, I know that f of 2 is equal to 4. Well, the inverse of fg, if I took g of both sides, the inverse function g at the x-coordinate 4 would have the y-coordinate 2. So I can plot 2, 4, but for the inverse function, I'd be able to plot the point 4, 2. If I have the point 1, 1, g would also have 1, 1. If I have the point 0, 0, g would also have the point 0, 0, g being the inverse of f. If I have the point negative 1, 1, let's think. If f of negative 1 is 1, what would g have the point? 1, negative 1, exactly. To kind of discover that, I can kind of take the g of both sides to show me that an x-coordinate of 1 plugged into g will give me a y-coordinate of negative 1. So I also have the point 1, negative 1. I'll have the point 4, negative 2. Giving me the inverse of f, which is this g. Okay, now this is kind of one point at a time discovering this, but if I wanted to find inverses of a function just in general and show that f and maybe g are inverses, you probably know the answer to this. What is the equation of this g right here? Does anybody know? Yep. Inverses are reflections over the y equals x axis. But what would x squared be reflected over the y equals x axis? Well, it's kind of going along this process. If I have 1, 1, or if I have like 2, 4, then I have the point 4, 2. If I have negative 2, 4, I have the point 4, negative 2. Well, all I need to do is say if I have y is equal to x squared, my inverse function will have the y's and x's flipped. If this is your equation for f, this would be an inverse equation, but it's not a function because it's not in terms of x. F of x in terms of, well, it's not a y in terms of x, it's x in terms of y. So what I'd have to do to this inverse equation is solve for y. Once I solve for y, I get y equals plus or minus root x. this would be my g of x. This graph is plus or minus root x. This is g of x equals plus or minus root x. Or you can use the equation x equals y squared would produce that. Okay? So to show that f and g are inverses, we need to show that f of g of x is equal to x. Okay, well, if g of x is plus or minus root x, and f of x is x squared, f of g of x would be f of g of x is plus or minus root x. Then if I plug in plus or minus root x in for x for f, this gives me plus or minus root x quantity squared, which is just x, which is what I wanted to show. So f and g are inverses. Cool. Well, we can find inverses of other equations that same way. Let's give you a different equation. Like if I wanted to find the inverse of f of x equals 3x plus 1, all I have to do is flip-flop the x's and the y's and then solve for y. And that would make sense, right? Inverses have kind of a corresponding point so that whatever you're doing to x, it's going to be mapped back to itself. So let's take this f of x is equal to 3x plus 1. If I ask you to find the inverse of it, you'd start by replacing the f of x with a y. You would swap your x's and your y's. And then you'd solve for y. X minus 1 over 3, right? Simple. If I wanted to confirm that they are inverses, well, I would have f of this g. This is g of x. So I'd plug in x minus 1 over 3. And then wherever I have x in f, I'd plug in x minus 1 over 3. So 3 times x minus 1 over 3 plus 1 should be x. This 3 cancels. I have negative 1 plus 1. That's just x. They're inverses. Okay? Which is interesting. Why don't you find the inverse of this guy really quickly? And I get x squared plus 3 over 2. Let's do one more. Find the inverse of that guy. Inverses aren't easy to find. Only select equations can we actually produce inverse functions. Our first equation, x squared, x equals y squared is the inverse equation. This is not a function. So I can't produce just one inverse function. I had to have a piecewise function. I had to have plus root x and minus root x. This would be the same thing. I can't find this in terms of y, so what we would just kind of say is like, well, this is my inverse equation, but there's not a function, okay? Whatever x I plug in, I might get 2 or more y's. So inverses are tricky. And our goal today is to be able to find derivatives of inverses. Our goal today is I'm going to give you this equation, and I'm going to ask you to find the derivative of the inverse at a specific x coordinate. Okay? Well, there's going to be three ways to do problems like this. And only one way works all the time, and it's easy to kind of deal with all the time. It's not this first way, it's not the second way. I'll show you the first ways and the second ways to do things, okay? So say I want to find the inverse of this derivative at x equals 1. So I want to find the inverse of this at x equals 1. So that's f inverse, or I can say g prime at 1. Well, if I have an equation where I can find the inverse function, well, then that's going to be easy. This is going to be the easiest one I can do. I just flip-flop my x's and my y's. I solve. This is my inverse function. I then can take the derivative of this function to get just x. Yep. And then I can plug in 1. I get 1. Right? Because it's 1/2 x squared. Take the derivative of 1/2 x squared. It's just x. Okay? Not that bad, right? Well, let's kind of look at this derivative at 1. I'm just going to do this really quickly. Take the derivative of this guy at 1. I get 1/2 2x minus 3 to the negative 1/2 times 2. I find f prime of 1. This won't be a great example because I can't take the square root of a negative value. So let's not do that. Never mind. Okay, so that's the first example. That only works if you can find the inverse function. If it's tough to find the inverse, I might have to derive implicitly. Now, how do I do that? Well, I know I can't solve this equation for y when I flip it. But I can take the derivative just of this implicit equation. And I'd get 1 is equal to 3y squared dy dx plus dy dx. And I could solve for dy dx to give me 1 over 3y squared plus 1. Well, what if I was asked to find f inverse prime at 1? Well, I have a derivative with y's. I can't plug in 1 to this, so even this is complicated. I need a y. I don't know what y is when I'm given x as 1. I need a point. Now, if I'm told that there's a point 1, 1 on f, I'll be able to figure out that when x is 1 for my inverse, y will also be 1. We'll get into that in a second. Don't stress out about it right now. So this would actually be 1 over 4. But let's get to the third way, the most crucial way, the inverse derivative formula, the way you will use for most, if not all, the problems you will encounter. Okay, and all comes from this fact. If f and g are inverses, that means f of g of x has to be equal to x. F will undo what g is doing to x, and we'll just get out x. So if I take the derivative of this on both sides, I'd use the chain rule to take the derivative of this piece. And I take the derivative of the outside, leave the inside, times the derivative of the inside, and that's going to be equal to 1. Well, what I can do is actually solve for g prime of x, and I get g prime of x is equal to 1 over f prime of g of x. I could also do the same thing with if f and f inverse are inverses. I'll do the same formula. You'd get f inverse prime at a value is equal to 1 over f prime of f inverse at that value. Now, this may look funky, and it does, but it's a simple thing. All this is saying is that the derivative, or the slope of the tangent, of an inverse function is equal to 1 over the slope of the original function at its corresponding point. Let me show you what I mean by that. I'm not going to do this problem just yet. If I know f of 2 is 4, well, I should know that g of 4 is 2. Right? You can kind of discover that by taking g of both sides, and you get g of 4 is equal to just 2 that's left up. Okay? Well, if I want to find g prime at 4, that's just equal to 1 over f prime of g of 4. Well, that's just equal to 1 over f prime at 2. If I want to know the derivative of an inverse function, all I need to look at is my original function and its derivative at its corresponding point. If you go from 4 to 2, I'm going to be looking at the derivative of f at 2. Visually, this is what it looks like. And this is the best way to kind of understand it is visually. Go back to here, your x squared and your y equals plus or minus root x. What that formula is saying is that the derivative at this point 2, 4, that derivative, that slope of the tangent, will be 1 over the slope of the tangent here. How can I show that? This is, what's the derivative of x squared at 2? It's 4, right? The slope equals 4. The slope here would be 1/4. That's kind of the corresponding point, the flip-flop point. You got 2, 4, you got 4, 2. The slope of x squared at 2, 4 is 4. The slope of x equals y squared at 4, 2 would be 1/4. Okay? Now, let's show you what problems will look like so you can see how we're going to do problems like this. Your problems will be, hey, here's a function, f of x. Find the derivative of the inverse. I'm going to change this to g. find g prime at 3, given that f of 6 is equal to 3. Here's what I'd like you to do, and you're going to get comfortable with it, and it's going to make sense. You're going to say, all right, g prime of 3, using the formula that I just developed, is equal to 1 over f prime of g of 3. So all I'm going to do is find the corresponding point that goes with this g of 3 that deals with f, and I'll be able to plug in that point and just find the derivative of that corresponding point using f. Okay? So the question is, what is g of 3? Does anybody know what g of 3 is? It's 6. It's actually given to us in our information. Now, sometimes it won't be given to you, but most of the times in this class it will, because it's kind of like a guess and check game if it's not given to you, or you have to solve for the inverse. The reason why I know it's 6 is because if I took f of both sides, I get 3 is equal to f of some missing value. Well, the missing value is given to us at 6. So g of 3 has to equal 6. Well, what looked like something tough where I'd need like switch x's and y's and then take the derivative just becomes something where I just need to find f prime at this value 6. How do I find f prime at 6? I just take the derivative of f and plug in 6. And there's my slope of my tangent, of my inverse function at that point. Okay, let's try the next one. I'm giving you the function. I also tell you that f of g of x is x. That tells you that f and g are inverses. My question is to find the derivative of the inverse of f, which is g, at 3. And I also give you just a random point. F of 1 is 3. Of course, that point is not very random. So I'll start it off. I think you guys can do the rest. G prime of 3 will equal 1 over f prime of g of 3. We first have to find g of 3. And then go from there. Take f of both sides to discover that 3 is f of some missing value. That helps me discover that g of 3 is 1. Just that corresponding point that goes with the f of 1. F of 1 is 3, so that means g of 3 has to be 1. So the problem just becomes, what is 1 over the derivative of f at 1? F prime is 8x minus 1, plug in 1, I get 7. My derivative is 1/7. Questions? Not bad, right? Well, here's an AP type problem. And this is actually easier than the last problem. But they don't give you any information. They just tell you that G and F are inverses. They give you F of 5 is 2. They give you F prime of 5 is equal to negative 1/2. They ask you to find G prime of 2. Use your formula. The derivative of the inverse is equal to 1 over the derivative of the original function at its corresponding x value. Piece of cake, right? It's not that bad. I don't think this is that bad if you just know how to use the formula. Well, it could be worse, actually. If you weren't given this information here, and if you weren't given this information up here, the problem gets more complicated. You kind of have to guess and check. But I will try to make it so that you'll be given all the information that you would be able to see on an AP question for your homework. I'll also put more examples of this on the rest of this video. Thank you. All right, let's look at this. Find G prime of 2. Now let's pretend I don't give you this information. That's gone. Now just find G prime of 2. And let's say I go ahead and know G and F are inverses, and I go ahead and use the inverse derivative formula. So G prime of x is equal to, or I can even go G prime of 2 would be equal to 1 over F prime of G of 2. All right. Well, the question is G of 2 is equal to what? If I kind of try to unveil the hidden information, I say 2 is equal to F of what? Well, that's like trying to solve this equation set equal to 2. What is the x value if this is a y value? So this was an x value, F wanted the y, but that would be flip-flopped for F. This would now be the y value. I need to find the corresponding x value. Now, how do you solve this? Well, you can't actually solve it by hand. You could use your calculator to solve it, or you can kind of see that 1 cubed plus 1 is 2. When x is 1, F of 1 is 2, which means G of 2 is 1. So G of 2, boom, is 1. So that's kind of like the thought process to finding these kind of hidden values where you'd have to solve your original equation set equal to the x value of your inverse. Which is why the AP test doesn't really do that. They kind of just give you the information they need you to know. They'll say, hey, this is F, and this is F of 1, it's 2, find G prime of 2. Well, you just kind of work backwards to figure out just 1 over F prime of G of 2, which is 1, F prime of 1. We find by taking the derivative and figuring out that it's 4. Okay, so the answer is 1/4 there. All right, so let's do a couple others. Here, another AP problem. All these problems, I say you must use the formula, and that's true. But I feel like the formula actually works the best for every single type of problem. Whether like this one, you can flip-flop your x's and your y's. You can find the inverse function, and you can take the derivative and plug in any x. But then once you get into something like this, you can't find the inverse function. Then you're stuck with taking the derivative implicitly, and that works, but you might end up with something that just has y's. And when I have something that just will have y's, I can't plug in an x that, I am asked to find. If I'm asked to find g prime of 3, I can't plug in 3 because that's a y. I have to figure out what the y is that goes with this inverse. When x is 3, I'd have to solve 3 is equal to y cubed plus y minus 1. That's not easy to do. So, kind of using your formula knowledge, using and being observant to the information given to you, that's going to help you. So here's another one. We have g is equal to f inverse. We're told f of 3 is 4, f prime of 4 is 9, f prime of 3 is 7. Question is, what is g of 3 and what's g prime of 3? Well, let's find g of 3. That's equal to some missing value. I take f of both sides to kind of discover this missing value. F of g, since they're inverses, just gives me 3, is equal to f of some missing value. I don't have that missing value. This is probably supposed to be f of 4 is equal to 3. Yep. There's probably supposed to be that as well. So let's say we now know that f of 4 is 3. So that means g of 3 is 4. I have g prime at 3 is now what I want to find. It's 1 over f prime of g of 3. G of 3 is 4, so it's 1 over f prime of 4. Hopefully I'm given that information. F prime of 4 I am given. It is 9. So this answer is 1 over 9. A couple more. Find f inverse prime of 3, and I'm given a table of information. All right, well, we have to be able to use the inverse derivative formula if I'm giving f inverse instead of g. So let's write down that formula if f inverse was used instead of g. So f inverse prime of x would be equal to 1 over the derivative of my original function at its corresponding inverse point. Okay, so that's it. I'll plug in 3 everywhere. Now, I need to find f inverse at 3. F inverse at 3. That's equal to some missing value. To discover this missing value, I'll take f of both sides to see that 3 is equal to f of some value. Well, here, f of some value should equal 3. It looks like f of 5 equals 3. So when x is 5, f of x is 3. F of 5 equals 3. Well, that means f inverse of 3 is equal to 5, if I took the inverse of both sides again. Okay, so this is really 1 over f prime of 5. F prime of 5 is negative 2. So I get 1 over negative 2. Now, not always will these derivatives of these inverses be fractions. You could have 1 over 1/2. I think we had that, negative 2. I guess here this is 4, this is 1/4. But if I looked at like 0.5, this would have been 1. If I looked at 0.25, this would have been at 1/4, and then this would have been at 4 right there. So just showing you that. I guess let's finish it off. Here's a bunch of information. Ask what's f inverse of 2 prime. So the derivative of the inverse at 2 will be equal to 1 over the derivative of the original at its corresponding inverse point. So that would be the corresponding y value, given that's an x value. I got to find that value first. What is f inverse prime of 2? It's equal to something. I take f of both sides. I get 2 is equal to f of some value. I look around, I say 2 is equal to f of 6. So, since this is the case, that means f inverse of 2 equals 6. So this becomes 1 over f prime of 6. F prime of 6 is negative 3. Piece of cake. Last one, find g prime of 3. Given g and f are inverses, so g prime of 3 would be equal to 1 over f prime of g of 3. G of 3, you probably get the hang of it. G of 3 is actually going to be 6, because f of 6 is 3. G of 3 will be equal to 6. We have 1 over f prime of 6. F prime of 6 is negative 2. So I am given more information than I need to know just to kind of send me off track, okay? So that's it. Mostly on your homework problems, just make sure you read the directions carefully. I'll probably add in extra information so that you don't really have to do the guess and check portion of things. You'll just have to be able to, apply the formula and go from there.